Hey, Verge.
Hi, Mark. Hi, everybody. Cinco de
Welcome to-
Mayo.
Welcome to AP Calculus AP.
Woo! Wow. Okay, that was loud.
Yeah, it's not May the 4th, but hey,
We're gonna celebrate it as long as we can, right?
We're gonna keep our Jedis out. So. All right, we are on Tuesday of our finale week, and let's see, my kids would be probably at lunch right now after the exam if we weren't in the situation we're in, but we have a week to the exam, so we're gonna go over yesterday's mock exam, and tomorrow and Thursday we're gonna repeat for a second set of questions, and then Friday we're gonna let Verge talk to you. She's got plans.
What? We have not made Friday's plans yet. You might need to watch the BC send off because it's going to be awesome. But the AB, we still working on other stuff here.
All right. So as you found out yesterday, as you will practice tomorrow, the exam on May 12th at 2 Eastern is 45 minutes long, a 25-minute question followed by a 5-minute upload, and then a 15-minute question followed by a 5-minute upload. And we still have these links here in the video. If you go to the Dropbox, it's linked down in the description. They're actually a shortcut to the video, and the PDF for that testing guide are both in that folder in the top level. So today, if you don't have your exam out, get your exam out. Get your answers.
You took yesterday, hopefully, or maybe this morning.
Have a marking implement of a different color or format or whatever, so that you can tell what you've added and what was there before. And if you don't have the questions yet, I guess go get the questions and come back in an hour.
Yeah. And the other thing is we are not going to post our answers for at least another day or so. So it's write them down and mark them up. I know several teachers are asking for students to send their corrected exams to them to indicate that they've gone through and made those corrections. So we're about to get started.
Yay.
Yay. So Mark, you're going to go ahead and go to your overhead, right? And work on sample question 1, and then we'll switch and I'll work on sample question 2.
That is correct. So yeah, there's a reminder of the stem here, and we're not going to start that timer.
And we didn't tell a joke yesterday, but I did want to tell you a math joke today, but I'm a little too squared to say it.
Yes. Here come the scares.
Okay, and to save time, because I know you guys are busy doing so many other things, I don't think we really need to read through the stem. I don't know. What do you think, Mark?
I think you guys spent time yesterday. We'll read it. We'll read and find things as necessary.
Okay, good idea.
Okay, so we've got part A. Find the derivative with respect to t of this product of t times the velocity of p at t when t is 1. So I said the magic word, right?
Product rule, yep.
And so we get v prime of t, f of t, plus f prime of t, velocity or v of t. And we're still wanting to evaluate that at t equals 1. V prime is not given anywhere in the stem, but it is. Right?
Yep.
It's the acceleration. And they happen to tell us that AP of 1 is -10. So.
That was you who wrote this question, Mark.
Right. Pay no attention to the man behind the curtain, right? F of 1. So now I'm going to go up to my graph, and F of 1. I don't think that's behind my picture up there. Although it is although it is behind my chat box. Hold on. Oh no, the chat box. Okay. So F of 1 is 1.
And that should be a -10 there, just so you know.
Thank you.
Yep.
Yeah, you think the guy that wrote it would remember that. See, evidence I didn't. All right. F prime of 1 is going to be the slope here. And it looks like it's going up 2 over 1, so it's 2. And then v sub p of 1, I have to pull off the table, and it's -29. Perfectly good in there, except I believe we said it indicate units. No, we didn't. No, there's no units. F isn't given in a context. So if you simplify, it's -68, but safest just to, once it's in, you can't leave it here. You can't just put ones in and walk away with it symbolic, but as soon as it's numeric, you can. So.
Yeah, that's an excellent point, Mark. And I also want to say, speaking of points, we are not going to delineate or parse how many points there are to each here. We have no idea. You should just be making corrections and learning from your mistakes and just do better tomorrow. And make sure that you've shown the same amount, if not more work than Mark did. So if you didn't, you might not get as many points in the real exam. So. Yeah. Oh, one other thing I was going to say is don't feel sad if you're getting stuff wrong. You're going to get stuff wrong. If you can get 50% of this correct, you're probably going to have a 3 or higher. Okay.
And on with that, it's better to make the mistake this week. You're less likely to do it next week if you make a careless mistake now. And
indeed.
Those kids who don't make a careless mistake now are actually like get confident, and then so. The other thing I would say is just from grading experience, we don't know how the points are parsed, but I would say getting a product rule form is going to earn you something, and then getting the correct product rule obviously is going to get you all of it evaluated correctly. Get it all right, you'll get all the points. All right, for B, we're doing a trapezoidal sum, and we're doing these 3 intervals that were given. There were some practice exams released online today, not practice exams, practice problems. We talked about that. Mm-hmm. They look very similar to this. They are not the same. I changed the table in order to make this flow a certain way. So if you look at that, the scoring is going to be different. The answers are going to be different. And we want to approximate this integral from 0 to 2.8. Verge, do you want me to do a left and a right, or do you want me to just do trap direct?
Whatever you do, I want to see sums and products. I don't just want to see a declared answer.
Absolutely.
So I know because one of my students sent me some work, and on his exam or practice exam, it was just basically a couple of numbers and then an answer. I'm like, where did these come from? You really need to see the setup to get.
You really need to see a sum of products, right? You don't even want to do the multiplication in your head. That's. Mm-hmm. All right, I'm going to go ahead and do the trapezoid just because that's how I did it the other day for myself. But
okay, and go ahead and push that up.
Yep, I got to squeeze it to try to get the table in there. All right, so my first interval is from 0 to 0.3, and so that means I have a width of 3/10, and then the 2 heights. And I'm going to go ahead and just do a global 1/2. So that's my point. My 0.3 is my width. My next width is 0.7. That's the 1 minus the 3/10. And then my 2 heights are 55 and -29. And my last one, because we're stopping at the 2.8, so don't go too far, that is a 1.8 width. And my bases, or the heights of my function, are -29 and 55. And that works as a numeric answer, doesn't it, Verge?
Yes, especially because you don't have any symbolic stuff like V of 1 and V of 0.3 and that kind of stuff. You actually have the numeric values pulled from the table.
Yeah, if you want to take your time and do that, you'll earn something with the setup, but this will earn the setup and the numeric if it's correct. Mm-hmm. So. And that, again, I know there's going to be people who want to know or have gotten out their fancy calculators, but I'm going to put it in a thought bubble. That should all work out to 40.75. Mm-hmm. All right. On to C. And I'm going to start folding.
Yeah.
And C is actually directly off of last year's exam. We actually didn't change it, I don't think. Was it a comment? I think it was a common question, wasn't it?
I really don't remember. I know that it wasn't our question. So.
Yeah. It was Jenny's. But if you're a BC student and took the exam last year and took the AB exam last year, and you're just here to help practice for the BC test this year, you did this. All right. So we've got -6 to 5 is 7, the integral from -6 of f of t. And you notice f of t stops. It's only from -2 to 5. So we need to figure out what's going on there. And then they
It's
say, all right,
defined from -6 to 5.
yeah, find the value of the integral from -6 to 2. So the integral from -6 to negative of f of t dt is going to equal what? Well, actually, that goes from -6. That's the part we can't see, right?
Yeah, I would do it negative.
So
Well, you do it whatever
I'm
you
gonna do
want. Yeah,
so
okay,
from
that's how I would do
-2
it.
to 5.
Mm-hmm.
This is not how I did it. I went straight to the difference, but I get it.
Okay.
Okay, so -6 to -2 and -2 to 5. That integral, those properties, we put those together. That's going to be the integral from -6 to 5. So that equals 7.
Mm-hmm.
So that's part of my setup. And I'm going to scoot now that I don't need that. Oh, and I know some people may say, hey, this says show the work, and A didn't. It's actually in the global directions for the exam that you show work even if it doesn't say so. They're just being nice and occasionally
They're just being nice to remind you occasionally, yes. Right?
Yep. So -6 to 2, -2 of f of t dt is going to equal 7 minus the integral of -2 to 5 of f of t dt. So now I really have what I really need, which is I need to find the integral from -2 to 5 of this graphic representation and subtract it from 7. And I hope you're listening. I hope you're not just watching this on 2 times speed, or I'm talking slow enough that I'm still making sense, because I'm not going to write everything. I have this triangle here that's a 1/2. I have this triangle that evaluates as -1/2. I'm not going to write those because those are going to cancel. I know there's some people who say, hey, maybe you should. That's fine. Maybe off to the side, make a note. But I'm worried more about this is what's left over.
Yeah, because those other
those
two
are
little
those two are both
cancel.
those guys are both little quarters.
Mm-hmm.
It doesn't hurt if you want to do this. My issue is if these numbers are wrong, you're probably not going to earn everything. And this is the meat. This is what I really want. And I did it this way. I don't know how you did this, Verge, but I broke it into 3 parts.
Yes, I see a 1, I see a 1, and I see a quarter of a circle and a
subtracted, right?
Square type thing, yeah.
Yeah, the circle's actually in here. And if I subtract that from the square,
I'll get
the area under that curve.
Yeah.
And so that has a, can you still, I'm probably under my head. So that has a radius of 3 and it's a quarter circle. So I'm going to add the whole square. I almost said rectangle, and I guess that would have been correct. And then subtract the quarter circle. Pi r squared, pi 3 squared. Well, that's a mouthful.
Yeah.
So, and again, these guys go away. Pew pew. 1 + 1 + 9 is 11. Of course, we can stop here, right? But I know I need this later, so actually neat. And then that's -4 + 9/4 pi is what it's going to have on the scoring guideline. But of course, we don't have to get there. All right. Moving right along. We're at D now?
Yep.
Okay. So D, fold this down a little bit farther. It says to integrate from 3 to 5, overfolded. All right. So I'm going to break that up. I'm going to break up the addition. I'm going to have 2 integrals from 3 to 5. And I'm also going to factor that 2 out because an integral is a sum, so I can pull out common multiples. So I'm integrating from 3 to 5 f prime of t dt, doubling that, and then adding the integral from 3 to 5 of 4. Excuse me. Fundamental theorem of calculus. Let's scoot this up. Says that that's going to be f of 5 minus f of 3. Because the integral of this is f, and I do f of b minus f of a. And I could do this I could do 4x from 3 to 5, but again, I'm going to do this
or 4t in this case.
Yeah. Sorry?
You said, or
4t. Oh, you're right.
4t in this
Yeah.
case, yeah.
Actually, X would work. It'd just be awkward.
Yeah.
It'd be equals. It's a numeric number, but yes, it would be weird. All right. Not to scale. Height's 4, width's 2. That's going to equal 8.
Mm-hmm.
And then I have to go pull f of 5 and f of 3 off the graph. And this graph is f. So f of 5 is 0. And f of 3 is crazy point on that circle. What do you think I should do about that, Verge?
I think you should read the stem. In
Where
particular, where they give you the point.
it is known that the point 3 minus square root of 5 is on the graph.
Yep.
So, and Verge has heard this story, but I had a student last year that went and found the equation of the circle, found that point, and then saw this on his way from the graph to the problem. But he got it. He made a 4. We're happy for him. Very proud of him. So that's gonna, and that's again numeric. You're done, but if you clean it up, it's 2. You get a -6 plus 8, and then the 2 times the double negative on the root 5.
Mm-hmm. Yep.
Yay.
Great. Yay.
Moving along.
Mm-hmm.
Also, don't be worried if you weren't doing these as fast as I'm doing them today. As Verge has pointed out, I wrote them. I have a little advantage of knowing what steps to take.
And actually, we've worked them like 4 times each already and gone over them with each other. So, you know, and we're going to do the same thing with our mock exam tomorrow that we're in the process of putting the finishing details on. So we can work them fast once we've worked them before. That's why you got to work as many problems as you can before next Tuesday.
All right. So now we have a new function, g. G is the integral of f of x dx, f of x with respect to x from -2 to t. So now we're looking for area under this curve. And I already played with the area under the curve, so that's going to be important. It says, find the absolute max of g interval. Well, Verge, where do maximums occur on closed intervals?
Well, that makes me think of the extreme value theorem. And so the candidates would be endpoints and also places where the derivative is equal to 0. So like horizontal tangents, and also places where the derivative might not exist, but the original function is defined. So there's 3 places. I think we were told, I mean, we know that G is differentiable, right? So that last one is.
Mm-hmm. Well, we're given the graph of f, right?
Yeah.
So.
Yeah.
And so this is our G prime. F is our G prime.
And G prime's continuous, so that implies differentiability, right? So, yeah.
And
right. So the easiest way I think to do this, and this is probably what Mark's going to do, is he's going to make do a candidates test where he makes a table of values. And because
it's actually what I was doing while you were talking.
Yeah, that
as you were saying.
Takes care of the justify part, because then you've shown that you've considered all of these possibilities, all these candidates.
And we're trying to maximize G of t, correct?
Yes.
So t, my candidates are 0, -1, 1/2, and 5. And there's some things we could do to eliminate candidates. We could look at what's happening with the derivative at those points and not test them. But I don't want to have to talk about why I eliminated them. So I'm just going to test them.
Can I interrupt for just a second?
Sure, just did.
On your on your table for the t, instead of 0, it should be -2, because that's your endpoint. You know what I mean? You were thinking to yourself that actually.
I was looking at that 0 right there, actually.
Okay, or maybe.
I wasn't even evaluating it yet. I was just looking at that.
Okay.
I think I read that as a point.
Okay. Okay.
So yes, these are all t's, right?
Mm-hmm.
All right. So here's my test: -2, -1, 1/2, and 5.
Mm-hmm.
My integral from -2 to 2 of f of x dx is going to be 0.
Upper bound -2.
Yup. Man, those guys are my bane this week. All right, actually not even this week, this fortnight it started. All right, so now if I go back to my graph, from -2 to -1 is that 1/2 triangle that we had skipped before.
Mm-hmm. Because we
I had tried to skip, and then I went ahead and wrote it anyway. So so all this work I did earlier.
It's coming back to help you.
Yes, exactly. All these pieces right here, where we were finding areas, we're using them right now. So by the time I get to that half, I've gone up a half, down a half, down a quarter. So it's -1/4. And I don't think they would have to write this work out here. What do you think, George?
No, no,
I don't think so
no.
at all, but I'm going to do it just because I've started.
Well,
and then
you've
the
made the
5.
connection between G prime
Right.
and
And
F.
I'm pulling in work from a previous section, so that
Mhm.
that. And now I'm doing this whole area, the integral from -2 to 5. Well, that was the part I subtracted out on that other one, right?
Yes.
This right here was my integral -2 to 5. It's labeled, so I can just use that. It's 11 minus 9/4 pi. And now I'm going to go back and see, what was I asked again?
Yeah.
Always. So, sorry, let me move my camera.
Yeah, because were you asked for the maximum or the minimum is what he's thinking.
Right, exactly.
Well, I've got this table. What am I supposed to say is my answer?
We're trying to find the absolute maximum. So the biggest number on this side, maximum of G. So we're pulling from the right side. The maximum of G on -2, 5 is 11 minus 9/4 pi. I actually probably, this is the way I coach my kids to do it, is G of 5 equals. So if anyone asks where it occurs, it occurs at 5. But
can I make a comment right now as students are grading their work? Many of them probably used calculators, and so they might be actually looking at decimals
that's a good point
right now. I actually left pi and square root and all that kind of stuff in my answer. So it doesn't matter whether you used a calculator or not, but you have to have 3 decimal place precision in your final answer, which means your intermediate answers need to be of higher precision oftentimes. So in this case, you would have needed to display 3.931.
Yep.
Okay. You don't have to have the pi in your answer, but your approximation needs to be correct to 3 decimal places.
Thank you for that. That was an excellent point.
Thank you. You're welcome. And that's going to happen. That's going to happen whenever we see an irrational answer, like
right.
Or
Absolutely.
a pi or a square root.
All right. Now we're using the same function G. So we're still playing with this integral.
I love how you say that we're playing with it. That's how I feel too. It's like it's so much fun.
Yeah, this integral here actually. I pointed at the wrong integral though, because this was behind your face. that's right. Using G of t from part E is the rate of change in G increasing or decreasing. So what I always tell my kids to do is cover up everything before increasing or decreasing, and then cover it up. And that's what I want to take the derivative of. So I want to take the derivative of the rate of change of G to find out if the rate of change of G is decreasing or increasing. So this tells me that I'm looking for G double prime.
G double prime will give us information.
Will tell me if G prime is increasing or decreasing.
Yep.
And so tell me if I go too cockeyed. I'm tilting this to make it easier to write. So G of t, G prime of t is f of t. So G for double prime of t is f prime of t. So at 3, so we're going to go back to our handy dandy graph, I think for one of the last times. And we're going to look at 3. How's that slope look?
Because it says f prime of 3.
Yeah,
so we're looking at the slope, not the
y
value.
We're looking at G prime, and it is going downhill. It has a negative slope. It is decreasing. So this is less than 0.
You don't have to say like how much.
Don't have to find the value, no.
Nope.
And so the rate of change of G is decreasing at t equals 3.
Nice.
And it said explain your reasoning. That's explanation, right?
Also linking how G and F are related from that definite integral.
Limit. All right. I am going to set this up just in case as if I was going to look for L'Hopital's rule. So if I do a visual, I can probably figure out what I can do, but I'm just going to look at each one separately.
Like you're going to make a 0 sandwich.
Right, just in case if these both equal 0 or both going towards infinity, then I can jump straight into my L'Hopital's rule and I have my supporting work. So f of 1. Wow. This
Back to the
graph is
graph.
getting, this graph's well loved at this point. F of 1 is 1. I think we've actually used that before.
Because that's the y coordinate.
So that's just e minus 3
Uh-huh.
in the numerator. And now my denominator.
So now we know we're out of L'Hopital's rule.
Right.
Like,
there is no L'Hopital's rule for if they both go to 3, e minus 3.
or if the denominator goes to 0, like it doesn't
Right.
matter. The numerator didn't go to 0.
Exactly. Then it would just be does not exist, and move on with your life. So now we're looking at the velocity of p at 1 minus cosine of pi. And the velocity of p at 1, you guys have the table. I'm not going to move all my papers around. It's negative 29 minus, and cosine of pi, I believe, is negative 1. So my limit, actually, I'm just going to write it on here. My limit is e minus 3. And I could leave it as negative 21 minus negative 1 or negative 28.
Yay! Mark, can I just ask one more question? Because put your limit stuff back up there that you just grabbed away. So I know it's fine, but just for clarity, like on that second limit that you have, you didn't actually write the function. It's totally correct.
Yeah, if I put the t in the t, because it does equal the evaluation.
Yeah. Just so people aren't confused. Although it wasn't mathematically incorrect, it's just a little bit.
It just happens to be they're the same this time, but yes, it is better that way.
Yay, excellent. And again, that one, e minus 3 over negative 28, you might have that as a decimal, so make sure you have it to 3 decimal places. Here goes Mark with his calculator.
Where's e hiding? And I didn't use parentheses, so we have to do it in 2 steps. Wow, that's tiny. Yep. And the leading zero is not necessary.
Yeah, and it has nothing to do with significant figures or significant digits.
Right. Yeah, it's accurate to 3, and if there's nothing written there, we're inserting the 0, and you're good. So.
I do want to say before I grab the screen that my students did submit their work to me yesterday, and there were some just general tips that I want to give to all students, my own students included, although I emailed all of them back. Before you do the live tomorrow, you should prep pages in advance, and that should have your AP ID and initials on the pages. And so what happened was, like, my students probably prepped 2 or 3 pages, but then they wrote on the back of one of the pages and it didn't have the AP ID on it. So I wouldn't write on the backs of any pages, because A, you won't have your AP ID and initials on it. And B, here comes the second part. When you take a picture and send it to your teacher or send it to yourself, it's not that clear if there's writing on both sides. Okay.
Yeah.
So
just to show you, this is a totally different problem, actually. Let's see. Yeah, here, this is old. We did this a while ago. But you see how there's writing behind it? And when you're taking a black and white picture, that'll show up, and sometimes it'll run into each other, and it's just you don't want to chance it.
So that would be my recommendation for tomorrow, is that you only write on the front side. Now, if you have copy paper available to you with no lines, and if you are an organized person in terms of how you work, you don't actually need the lines to work, I would try doing it on copy paper just to see how that is compared to notebook paper. Because some of the notebook paper, the lines like overshadow my students' handwriting. I would try that for tomorrow. And the other thing, as I'm grabbing the screen here, is I would also disable the live photo. I don't know if Androids have that, but
no, that's an iPhone specific thing.
You can't be sending a live photo for your AP exam.
It's HEIC or HIEC. It's a different format than JPEG or PNG. So
so I
just
got
disable the Apple Live, and you're okay.
Yeah, it's gonna be frustrating. Okay, do the demo. All right, Cinco de Mayo. I don't even know which AP Live this is. That's why I did. Okay, bye. All right, so this is our second sample question. And this was the cylindrical barrel with a diameter of 6 meters, yada, yada, yada. Okay, in part A, what you were supposed to do was find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 10 meters. Indicate units of measure. Now, because this is a cylinder, the radius of the cylinder is always the same. So before I start taking the derivative of the volume, what I can do is I can rewrite this volume equation by substituting in that constant radius. In calculus, usually everything is changing. That's the whole point of calculus. But if something is truly constant, it's not that it equals it at that moment in time, it's that it equals it always, then you can sub it in before you take the derivative. It'll make your life a lot easier. So that's would be my advice on this one. You could do product rule and all that, but it's going to be a little easier to rewrite. V is equal to pi times my radius is going to be 3 in this case, because the diameter is 6. And then times my height. So my volume is equal to 9 pi h, I believe. Is that good, Mark?
Yes.
Okay.
That's what I have.
Okay. So then I want to find the rate of change of the volume when the water is 10 meters. Okay. So I want dV dt is equal to, now the derivative of 9 pi h is going to be 9 pi dH dt. When the height of the water is 10 meters, that means I need to plug 10 in for h. Uh-oh, I don't have an h. Oh, but wait a minute. Yes, I do. Because this equation right here, this differential equation, is in terms of h. So I can rewrite this to be 9 pi and then times -1/5 root h, okay? And then when I evaluate this at, I don't know if this is correct notation, but I do this all the time. And when I evaluate this at h equals 10, I get -9 pi all divided by 5, and then times square root of 10. So that square root of 10 is up in the numerator, or you can write it out on the side. It doesn't really matter. Now, this is the one that in particular, I saw a lot of decimal answers when I was looking at my students' work on this. So, Mark, do you have your calculator nearby?
I'm doing it.
Okay. While he's doing that, let me also say, it says indicate units of measure. So we took the volume with respect to time. So our units are going to be, volume is, what the heck was this? Meters. So meters cubed with respect to time, and the time was in seconds. So definitely make sure you have your units there. And what was this as a decimal, Mark?
-17.882, and it's 8822. So that's the only acceptable. You don't have to
either
worry about
rounded
rounding.
or truncated. Yeah. So either one of these would be. Boy, we wrote some good problems then, huh?
Yeah.
Rounded and truncated.
Just like we planned it.
Yeah, right. Okay, so either of these answers are fine. Now, I've had several emails from students and teachers, of course, but one student, many students have said, should you box your answers or not? And I said, that's personal preference. Me personally, I box my answers because when I'm going back and checking my work, I need to know like what I thought the answer was. Mark does not. So if this,
that's not true. I actually box mine. I don't always box it. I'm agnostic.
Okay, I probably wouldn't have put the decimal there.
I believe in it. I believe it exists.
Yeah. This is probably what the answer would have looked like, assuming I got it right. Which, that may or may not be true. All right. So part B, and I'm going to go ahead and do some folding as well. So I kind of pre-folded the part A, but I'm going to go ahead and fold down for part B. For part B, it says, when the height of the water is 8 meters, is the rate of change of the height of the water with respect to time increasing or decreasing? This reminds me of what Mark just told us that we should do. We're looking for understanding whether the rate of change of the height is increasing or decreasing. That means I need to look at the second derivative. I need to think about the sign, SIGN, of the second derivative. So I need to take the derivative of dH dt with respect to t. And then if it's positive, I know that increasing. If it's negative, I know that decreasing. Okay, so the second derivative here, d squared h dt squared is equal to -1/5 And then times the derivative of the square root of h. Now you can do that a couple of different ways. If you've been with us for a long time, since
Yes.
March 25th, you know that I do it like this. I have it memorized. I know that the square root of h, when I take the derivative of it, or the square root of x or the square root of y, is going to be 1 over 2 square root of h. But you can, of course, do power rule on that as well, where, if y is equal to the square root of x, then you can rewrite it as as x to the 1/2 and do power rule.
But by the way, we're just going to interrupt because we can, right? Episode 30.
Episode what?
You asked what you said. You forgot which day we were.
Mm-hmm.
But May 25th was a Wednesday. It's been 6 weeks, so this is 30.
Oh my gosh! I have
Tomorrow will be 31
because
it's the start of a 7th week or whatever. But
wow. Yeah. I've been sitting in this chair for a long time. It's getting creakier and creakier. Okay. Now, this is the part where we've done a lot of these dw dt, db dt, dg dt. If you're looking for the second derivative, don't forget about that implicit differential chain, like chain out the derivative of h with respect to t. So that's going to be dh dt. So this is that second derivative, chain rule. Now I want to figure out what's going on when the height of the water is 8. Well, I'm going to go ahead and replace dh dt with my expression here. So this is the same as -1/5 times 1 over 2 root h, and then times -1/5 root h. And look what happens here. Pew, pew. Those two take each other out. We don't care where they go, right?
And some of you may have gone to nasty decimals and found these two numbers separately and then multiplied them together. Mm-hmm. That's fine. They'll still cancel, and you will get 0.02.
Yes, 1/50th or 0.02, which this is actually irrelevant. We just need to realize that this is less than 0.
Greater.
Say it again.
It's positive.
Oh, sorry. I don't know what I'm doing. Yes, I do. I do know what I'm doing. I'm
yes, you do.
No, my internet is so flaky that
you're gonna blame the less than on lagging?
No, it's not that it was lagging. I get a little thing through Zoom that says your internet connection is unstable. Do you get that when yours is doing that or not? Or maybe
Fortunately,
your internet's
no. Fine. The only time I got that was the one time I almost lost you.
Oh, okay. Anyway, yes, 1/50th is greater than 0. So that means the rate of change of the height of the water with respect to time is always increasing, right?
Yep.
Okay.
And the only reason I brought up the lagging thing is the gamers will appreciate it. That's a big gamer thing. Like, oh, there's lag. That's why I messed up.
I would be so dead so fast if I were playing Fortnite or whatever. It would be bad. Okay, last part, my favorite. Okay, the last part, you were specifically told to use separation of variables. So that should be a hint, hint, wink, wink, nod, nod. That's like we are trying to find the particular solution here to this differential equation, dh dt equals -1/5 square root of h. At time t equals 0 seconds, the height of the water is 16. So that's our, h of 0 equals 16. That's our point. And then we have our differential equation. So let's see. What I would probably do is I'm going to just recopy the differential equation here. dh dt is equal to -1/5 square root of h. First step, separate. So I need to divide both sides by root h, or move that root h over to the other side, is equal to -1/5 dt. Then I need to anti-differentiate here. You can think of this, and I'm going to go ahead and nod to the power rule here, which I might not normally do, but I'll just, so that I can kind of cover all my bases. You can rewrite dh divided by square root of h as h to the -1/2. Then add 1 to your -1/2 and get +1/2. And then divide by that new exponent, which means multiplying by 2. So I get 2h to the 1/2 equals, over here, I'm just going to get -1/5 t and then plus that c. We did tons of lessons on differential equations, if you want to go back and rewatch them at regular speed. I watched us in double speed, Mark, the other day. I was like, this is insanity. Like, it's like Munchkin math or something like that. All right, now you've done a whole lot of calculus. Now use that initial condition before you go ahead and solve for h. So 2, and then in parentheses, 16 to the 1/2 equals -1/5, 0 plus c. 16 to the 1/2 is 4, and 2 times 4 is 8. So c ends up being 8.
That's what I got.
And it says, find an expression for h in terms of t. That means I need to rewrite and solve for h. From here on in, it's straight algebra. And it's usually worth a very small amount of points, if any, just like 1 point, but still a good point to earn.
So hopefully an easy one to earn,
but this point, and I know because I looked at all my students' work, the wheels fell off, even on my best students. So I'm glad they fell off yesterday, because they're not going to hopefully fall off a week from today. Here's my plus c. Divide everything by 2. So I get h to the 1/2 equals, you could write it as -1/5 t plus 8 all over 2 if you're nervous about how to handle that fraction. You could also write it as square root of h equals -1/10 t plus 4, because that's what happens when you divide each of those terms by 2. Now, how do I get rid of a square root? Not
square.
by using a square root. I
Inverse.
square it. Why
Inverse.
do you think I picked this joke today? Yeah, don't be a little squared. No, I mean, like, go ahead and you got to square both sides, not take the square root of both sides. All right, so h is equal to this binomial.
And no plus or minus.
Right, and no plus or minus. This is equal to this binomial squared. Yay. Now stop. Don't distribute this exponent and come up with a binomial expression. This, if I were to expand it, would be, let's go ahead, Mark.
1/100th t plus 4/5.
I think
minus 4/5. Minus 4/5. You're right.
It's hard to do it on the fly, right?
The 8/10, yeah. So, yay! But don't.
Okay, but don't. But if you have taken it further than this, it has to be correct. It has to be correct. If you took it further than this, and I'm talking to a few of my students in particular who did beautiful work, but then took it a little too far. So just be aware of that. Mark and I were actually the question leaders for this sort of a question last year, and we saw some
a lot of bad algebra. A lot of bad
algebra, but great calculus.
Yeah, calculus is fine. Yeah, so there you are, right?
Yeah. Leave it like this.
In my own classroom, I actually yell stop pretty loud when we get to stuff like that. And it's funny because I'm next to an English teacher who teaches my Algebra 2 kids, and they'll come to class. They're like, what were you yelling at the calculus kids for?
That's hilarious. I'm going to have to try that. Stop!
Oh, yeah. It's just I'll put the mic. Stop! It's like, it's like, what?
That's
like,
good.
what did I do wrong? I do the same thing with lines.
So again, please don't freak out if you got a lot of this wrong. That is why we practice.
That's right.
Maybe do the test again for yourself later on this afternoon or tonight and see if you can get more points. Shoot, when I have to do a squeeze theorem problem, I always have to do it twice to get all the points. Like, that's just the way it is. I'm just saying, like, it's about your practice.
They released the older versions that we kind of modified and manipulated. We changed some parts, but for the most part, there's basically other versions of these now on that AP coronavirus updates page.
Oh, that's a good point. They could just download
do those and see, and it'll pull the same skills in, but you'll still have to pay close attention. And just FYI, where my dad lives in Arizona, apparently all of the kids from the high school in Oro Valley are watching. So hi.
Okay. Yeah, because tomorrow we're gonna have another mock exam, and we are almost done putting the finishing touches on it. It's going to be challenging at parts for sure, but also some easy points to get the easy points. You know what I mean?
Yes.
You got to get the easy points, and then work on trying to get some of those hard points as well. Okay, because you can do it. Remember, you only have to get like half of this stuff right to make a 3 or to score a 3. I know some of you guys are gunning for the 4 and the 5, and that's fabulous. So please don't stress yourself out if you're getting stuff wrong. You can do it. Okay.
You just know how to do every part. It's just a matter of recognizing what you're being asked, and that's what we're trying to do these days.
Yep. I don't know. You're going to go back to the slideshow there, Mark?
Yeah, I guess I should.
Okay.
There it is. Okay, so you know this. It's not letting me advance, but you know it. Okay. Links to the Dropbox. Those things are also easy to find online. Our thank you. There's the Dropbox itself if you want to grab that with your phone real quick. The mock exam is not in the Dropbox though. It's in that link earlier in the video. So you'll have to go there. Don't try to read these. These are the things we went through yesterday. We'll go through these before the exam again tomorrow pretty quickly, but just get used to how we have to submit. This one, you might want to take a screenshot. A lot of these are in the description below, just where everything is, the walkthroughs and whatnot. So thanks,
and remember,
everybody.
We're going to post these answers probably tomorrow or the next day. So if you've gone through too quickly and your teacher wants you to submit this stuff, you're going to need to be careful.
Watch the video.
Watch the video. That's right.
Yeah. I'm halfway through typing them up, and typing them up is not fun. So, all right. Bye, Verge.
Yeah. Bye, Mark.